Today we're going to find slopes of lines and use them to determine line relationships. So you should remember from Algebra 1 that the slope of a line is calculated by looking at 2 points. We'll call them x1, y1, and x2, y2, and taking the change in y, y2 minus y1, over the change in x. Now, it's not important which point is listed first. What is important is that whichever y value is first on top is tied with whatever x value is first on bottom. They need to come from the same point. Okay? If you crisscross, you're going to end up getting the opposite slope from what you want. So this is another way to define this, or another way of looking at this, is change in y, not charge in y, change in y over change in x. Another way of looking at it is how much the line is rising over how much it's running, how much is going up and down over how much is going side to side. And normally the letter, the variable we use to symbolize slope, is m. So in the y equals mx plus b, it's the m that is the slope. Now there's 4 different types of slope that you can have. You can have on your graph a positive slope, which rises when you go from left to right. That is a positive slope. You can have a negative slope. That falls as you go from left to right. Now, if you got positive, negative, what's another choice?
Zero.
Zero slope.
That's horizontal.
That's horizontal. Doesn't rise or fall. That wasn't quite horizontal. Let's try that again. That's a little better. There's our horizontal line. Has a zero slope. Then you got a 4th type. Yeah. An undefined slope for a vertical line.
Don't we use the vertical one, like when you're like shading in the graph?
Sometimes.
Like the one side.
Sometimes. Okay, there's our 4 types of slope. And so in order to find the values of the slope, we need a couple of points on the line. So example 1 gives us a graph with several lines on it. And they ask us to find a couple of the slopes. The first one they want us to find is the slope of line A. So we need to pick 2 points on the line. What 2 points do we have? 6, 4, and 8, 2. So if we plug those into our slope equation, what do we want to put first on top?
You're going to do the y.
Okay, what y do we want to put first? That's an x. 2. So if we put 2 first on top, what has to go first on the bottom? 6. Are you sure about that? 4. Are you sure about that? First on the bottom is going to be 8. Okay. First y has to go with the first x. They come from the same point. Okay. So what's the second y?
It would be 4.
Minus 4. And the second x?
6.
Okay, so on top, what do we get? Negative 2. And on the bottom?
2.
Positive 2. And when we divide, what do we get for the slope of A? Negative 1. Now let's check and make sure that makes sense. Negative slope should be falling as we go from left to right. Is line A doing that?
Yes.
Yes. Awesome. So that is the slope of line A. How about the slope of line D? What would that be? Undefined. It's a perfectly vertical line, so the slope of line D is undefined.
So you didn't have to solve.
No, we could if we wanted to, though. For D, we've got 6, 0, and 6, 4, right?
Yes.
So on top we have the change in y. We could do 4 minus 0. And on bottom we have 6 minus 6.
So that'd be 4 over 0.
4 over 0. And we can't divide by 0. It's undefined. That's why we have an undefined slope. Okay? All right, so I want you to take a second on your own. Oh, we'll pause the video. And we will give you a chance to find the slopes of line B and C. And then we'll go over them together. All right, so let's start with B. We have 2 points on B. 6, 4, and 4, 0. So what do we want to subtract on top?
0 minus 4.
Okay, so if we do 0 minus 4, we got 0 first on top. What goes first on bottom?
4.
If the 0's first, the 4's got to go first. And we've got 4 minus 6. So 0 minus 4 is,
Negative 4 over negative 2.
and 4 minus 6 is negative 2. And negative 4 divided by negative 2 is 2. So B has a slope of positive 2. What is the slope of C? Yeah. How do you know? Because it's a horizontal line. Now, if you wanted to calculate that, you would take your 6, 4 and your 1, 4, and we do the difference of y's on top, which is 4 minus 4 over 6 minus 1, and we get 0 over 5, and 0 divided by anything is 0. Make sense? Okay, now we have 2 postulates. Postulate 17 is slopes of parallel lines. And parallel lines have the same slope. Perpendicular lines is postulate 18. The slopes of perpendicular lines, it says that if 2 lines are perpendicular, then the slope of one line times the slope of the second line is equal to negative 1. Now, another way of putting that is if we divide both sides by m2, we get the slope of one line is the opposite reciprocal of the other slope. Opposite reciprocal, you flip them and make it the opposite. So if it's negative, you make it positive. If it's positive, you make it negative. So in example 2, we need to calculate the slope and determine which lines are parallel. Now, we're going to use a little shortcut, which is easy to do when we have a graph. It's a little harder to do if you just have the points, but when you have the graph, it's a little easier. Because remember, we define slope as rise over run. How much a graph rises between 2 points over how much it runs. So let's look at K1 here. And between these 2 points, how many does it rise?
4.
4 units. How much does it run? 1. And is that a positive or negative slope? Positive, because it's going uphill. So our slope is positive 4. Okay, a rise of 4 over a run of 1. Number 2, K2, between those 2 points, what's the rise? What's the run? Positive or negative? Positive. So it also has a slope of 4. So K1 and K2 are parallel. Now K3, between those 2 points, what's the rise? 5.
5.
And what's the run?
1.
1. For a slope of? Is that parallel to the other 2 lines? No. Okay. So K1 and K2 are parallel because they have the same slope. Everybody good so far? The last one tells us that line H passes through the points 3, 0 and 7, 6. So line H has the points 3, 0 and 7, 6. So I'm going to start by graphing line H. So my first point is 3, 0. Where's that? 3 to the right of the origin, right there. And where is 7, 6? 7 to the right, 6 up. Okay. So there's line H. Everybody okay with that? They want us to graph a line perpendicular to h that passes through the point 2, 5. Okay? So it needs to pass through the point 2, 5 right here and be perpendicular to h. Now, we know that if they're perpendicular, then they have opposite reciprocal slopes, right? So if we can find the slope of h, then we can use that to find the slope of our new line, right? So what's our slope of h? This point was 7, 6. This point was 3, 0. If we do our calculation, what are we subtracting on top? 6 minus 0, so what on bottom? 7 minus 3. What do we get?
3/2.
6 over 4, which reduces to 3 over 2. So if the slope of h is 3 over 2, what's the slope of the new line? Close. Opposite reciprocal, which is negative 2/3. Okay? So here's what we can do. We don't have to come up with an equation. Okay? We just have to draw the line. So, first of all, negative means what?
Left to right.
From left to right, it's going down. And it's going down at a rate of 2 over 3. So it's rising or falling 2 units for every 3 it runs, which puts a point right there. Make sense? If you want to draw another point, it'd be down another 2 over another 3. So our new line, our perpendicular line, is right there. Does that make sense? So parallel lines have the same slope, perpendicular lines have opposite reciprocal slopes. Any questions? All right.